Hi students, welcome to online class. So last video we discussed about the chapter 2 number systems. In that first we have discussed about the data representation. So in this video also we are going to continue the data representation and memory sizes. So we are going to discuss about data representation and memory sizes. So last video we studied that data. Computer can accept only zeros or ones. So that is called machine language. See the data, the basic data unit is bit. What is mean by bit? 0 or 1. Then we studied about nibble. Nibble means collection of 4 bits. Then what about byte we studied? Collection of 8 bits is called as 1 byte. Then we studied about kilobyte, megabyte and then giga and then tera. So now in this video we are going to discuss in detail about those things. So computer memory, there are two types of memory are there. I think in the first lesson you might have studied. There are two different types of memory. What are they? One is called primary memory and another one is called secondary memory. You have studied. Here we are calling with the name called main memory and secondary storage. See, the primary memory is otherwise called as main memory and then secondary memory is otherwise called as secondary storage. See, everybody you might have understood this in a very simple manner. Everybody now they are using Android mobile phone. So whenever you purchase the mobile phone, we used to check how much the RAM capacity, right? How much is the internal storage? See, if your mobile is 2 GB RAM or 3 GB, 4 GB RAM, so that is what here they used to call it as main memory, right? And then what about your internal storage? So that is what they used to call it as secondary storage, right? Just to think with your real life, just to compare everything in your real life. Don't go for technical terms. Everything, whatever we are using, everything is related with the everything, whatever we are using in our real life, everything is related to the subjects. Right, computer science we are studying here. So just we don't know about the technical term, but we are using in our real life, right? Okay. So computer memory, that is main memory and secondary storage, is normally represented in terms of kilobyte or megabyte. Now most of them we are not using kilobyte and megabyte. Yes, if whenever you go for a computer, we are asking GB. Or some of them they used to go for TB, 1 TB hard disk. Whatever the usage we are going to use, we don't know, but we need more capacity, because most of them they are using only for seeing movies and then storing the music and then playing the games. For that purpose only most of them they are using the computer. So they need more amount of storage. But actually the computer usage is not like that. We can use the computer for entertainment purpose for particular time only. We should not use the whole computer, whole machine for fully entertainment purpose. Right? So it is used. It can be used for education purpose also. So you should keep it in mind. Right? So the computer memory is normally represented in terms of kilobyte or megabyte. In decimal system, 1 kilo. So last video itself I told 1 kilo represents 1000 gram, right? But here that is 1 kilo represents 1000, that is 10 to the power of 3. So 10 into 10 100, 100 into 10 it becomes 1000. But what about computer? In binary system, 1 kilobyte represents 1024 bytes. 1 kilobyte represents 1024 bytes. That is 2 to the power of 10. 2 to the power of 10. So last video itself we discussed. Right. We are going to discuss the memory sizes. that is different. The following table represents the various memory sizes. See, first of all, kilo. Kilo they used to represent by K, that is KB, right? Kilo. Then mega, M. Then giga, G. Like that tera, T. Like that peta, P. Then exa, E. Exa represents E. Then zeta. Zeta represents Z. Then iota represents Y. Right? See, kilo means kilobyte. So that is 2 to the power of 10. This caret symbol, this is called a caret symbol. This represents 2 to the power of 10. Like that mega. Mega represents M, 2 to the power of 20. Like that giga. Giga represents 2 to the power of 30. Then terabyte, TB, that represents 2 to the power of 40. Like that peta, P, that represents 2 to the power of 50. Like that hexa. Hexa represents 2 to the power of 60. Zeta, Z represents 2 to the power of 70. Then iota. Iota represents 2 to the power of 80. Right? After that we have another 2, that is 2 to the power of 90 and 2 to the power of 100. Right? Students, I shall give you a quiz, or else I can ask you a question. Try to answer this question to your subject teachers. After the 2 power of 80, that is iota, you have another 2 things. You can find out in the internet. Try to answer that question. 2 power 90, what it represents, and then 2 to the power of 100, what it represents. Try to find out in the internet and then try to answer to your subject teacher. So 2 to the power of 10 to we have 2 to the power of 100, but in your book they have given only 2 to the power of 80. There are another 2 memory sizes are there, 2 to the power of 90 and 2 to the power of 100. Just try to find out, so that we can see how much students are very eager in the computer science subject. Right? Can you understand, students? Kilobyte, megabyte, gigabyte, terabyte, and then petabyte, exabyte, zettabyte, and then yottabyte. Right? For that they have given the multiplication 2 to the power of 80, like that they have given. So it takes a plenty of time. We no need to go for that. Just we want to know the names and the abbreviation as well as the memory sizes. Right? Now we can see the memory sizes in a detailed manner. Bytes are used to represent characters in a text. Already we studied it. Whenever we give in the computer, whenever we give the input to the computer, each and every character is converted into byte. Each and every character is converted to byte. There are different types of coding schemes are used to represent the character set and numbers. There are different types of coding schemes are used to represent the character set and numbers. In that, we are using the ASCII system, that is ASCII coding system. What is mean by ASCII? See, ASCII. ASCII means American Standard Code for Information Interchange. Each and every word, the first letter that represents ASCII, American Standard Code for Information Interchange. See here, this is the system what we are now using. But apart from ASCII, there are different coding schemes are there, like Unicode, and then EBC, DIC, like that several TSC, II, like that several coding schemes are there. You will study in detail one by one. So most commonly we are using the ASCII system. Each binary value between 0 and 127 is used to represent a specific character. See, from the binary value 0 and to 127, So 0, 1, 2, 3, 4, like that each and every decimal number 0, 1, 2, 3, like that it goes on up to 100, 101, 102, up to 127. Each and every decimal number represents a binary value. That binary value is going to represent a particular character in the computer. Whatever the character we are pressing, A, S, E, R, each and every character is converted to 8-bit binary number. Right? So that is what here they are specifying. Right now we can see that ASCII value. See here, the ASCII value for blank space is 32. So whenever we press spacebar in the system, the computer accepts the spacebar as a 32 number. The computer accepts the spacebar as a 32 number. Then this 32 is converted into zeros and ones. Then the zeros and ones are accepted by the computer. So like that there is an ASCII value for numeric 0. Whenever we press the number 0 in the system, that is converted to 48. It is not considered as 0. It is considered as 48. Then 48 is converted to zeros and ones. Can you understand, students? Again I repeat. So whenever we press space bar, that is blank space in the system, it is considering as 32. The 32 is the ASCII value. 32 is the ASCII value, and then this 32 value is converted to zeros and ones. Like that numeric 0. Numeric 0 means number 0 is considered as 48. The ASCII value for 0 is 48. Then 48 is converted to zeros and ones. Like that, the range of ASCII values for lowercase alphabets. What is mean by lowercase alphabets? Lowercase means small letters. So whenever we type the small letters in the system, that is A to Z. Whenever we type the small letters in the system A to Z, it is converted to 97 to 122. For example, if I type small a, it changes to 97. For example, if I type small b, it changes to 98. Small c, 99. Like that it goes on from 97 to 122. That is small a to small z. So that is called lowercase alphabets. Like that, the range of ASCII values for the uppercase alphabets. Uppercase means capital letters. Capital letters, it stands for 65 to 90. Right? 65 to 90. That means capital A that represents 65. Capital B that represents 66. Can you understand, students? Like that it goes on up to capital Z. So when I press capital Z in the system, it is converted to ASCII value 90. Then 90 is converted into zeros and ones. Right. The speed of the computer depends upon the number of bits it can process at once. So here what they are trying to say, each and every computer speed is represented by the number of bits it can process. If you are using a 32-bit system, and then if your friend is using a 64-bit system, which can process in a faster manner? Whether your system or your friend's system, the system which contains 64-bit will process in a faster manner. Why? Because 32-bit system can process only 32 bits per second. But what about the 64-bit system means? The 64-bit system can process 64 bits at a time. But 32-bit it cannot process at a time. It can process only 32 only. But what about 64? It can process more than 32. That is twice. So that is what here they are trying to say. For example, a 64-bit computer can process 64-bit numbers in one operation, while a 32-bit computer breaks 64 number down into smaller pieces, making it slower. So that's what you can see now. Most of the computers are 64-bit systems. Most of them we are using the 64-bit system, and then you are using Windows 8.1 or Windows 10 like that, latest versions, so that your computer will be much faster. So that is what here they are saying. The speed of the computer depends on the number of bits it can process at once, at a time. At once means per operation, at a time. Can you understand, students? Can you understand the ASCII values? Right. Now we are going to discuss about the number systems. Number system. What is mean by number systems? See, actually the computer has 4 different types of number systems. What are they? First one is binary number system. Then second one is decimal number system. Then third one is octal number system. And then last one is hexadecimal number system. So what is mean by binary number system? Binary number system means which contains the base value as 2. Base value is 2, that is 0 and 1. It contains only 2 values, that is 0 and 1. What about decimal number system? The decimal number system contains the base value as 10. Actually here it is given wrong. You change it in the, I think you can see in your book. So the base value is 10. So base value is 10 means 0 to 9. Base value is 10 means 0 to 9. So I have done a mistake here. You try to change in your notes. So base value is 10. That is 0 to 9. Then what about octal? Octal means the base value is 8. That is 0 to 7. So the numbers are 0 to 7. 0, 1, 2, 3, 4, 5, 6, 7. Like that, when I go for hexadecimal, it is taking as the base value as 16. The base value is 16. That is 0 to 9. After that 9, 10, 11, 12, 13, 14, 15, 16. All are 2-digit numbers. Is it right or not? 10, 11, 12, 13, 14, 15, 16. All are 2-digit numbers. So we should not represent in 2-digit number. We should represent in only 1 digit. So after the 9, all the numbers are changed to alphabets. All the numbers are changed to alphabets. That is 10 represents A, 11 represents B, 12 represents C, 13 represents D, 14 represents E, 15 represents F. So 0 to 15 is represented by 0 to 9. Then after the 9, it is represented by the alphabets A, B, C, D, E, F. It is represented by the alphabets A, B, C, D, E, F. So totally there are 4 number systems are there. What are they? Binary, decimal, octal, and then hexadecimal. What is the base of binary? 2. What is the base of decimal? 10. What is the base of octal? 8. What is the base of hexadecimal? 16. Right? Can you understand, students? Right. Now we are going to see the last topic in this. So byte and word length. So again and again we are going to see the same. Not byte and word length. We are going to discuss about the number systems and radix. Number system and radix. So a numbering system. What is mean by numbering system? What is the most commonly used numbering system? Numbering system is a way of representing the numbers. Numbering system is a way of representing the numbers. The most commonly used numbering system in real life is decimal number system. Which is the most commonly used number system? Decimal number system is the most commonly used number system. Apart from that, we have binary and then octal and then hexadecimal number system. Each and every number system is identified by its base value or radix. So that is what we have studied in the last slide. What is the base value of binary? 2. What is the base value of octal? 8. So base value here it represents as radix. It is otherwise called as radix. So what is mean by radix? Radix or base is the count of number of digits in each and every number system. So how many numbers are there in the number system? That is what they used to call it as radix or base. For example, binary base is 2. So how many numbers are in that system? Only 2 numbers. What are they? 0 and 1. What is the base of octal number system? The base of octal number system is 8. So how many numbers are there? 8 numbers are there. 0, 1, 2, 3, 4, 5, 6 and then 7. So 0 to 7. So totally 8 numbers are there. Can you understand, students? So radix or base is the count of number of digits in each and every number system. So radix or base is the general idea behind positional numbering system. So this is the basic idea behind the positional numbering system. So with this only we can represent each and every number system that is used to uniquely identify each and every number system. Right. So in this video we discussed about the memory sizes, and then we discussed about the different numbering systems. I think you might have understood all this content. So let's end the class. So thank you, students.